That was the first one. Let's try one more example. So on this next example, I've got a little bit more complicated. This is number 3 on your worksheet. And I've got a function that looks a little bit more complicated. The first thing I want to do is I want to find the domain again, right? So the domain, as we noticed up here, it says domain, set the denominator equal to 0. So I'm going to set the denominator equal to 0. So I'm going to go x squared plus 5x plus 6 is equal to 0. Well, this factors, right? So I'm going to go ahead and say that x plus 2 and x plus 3 is equal to 0. That means x will be negative 2 and x will be negative 3, right? These are the values that x cannot be in my domain. So what's so my domain in this particular one is that x cannot be negative 3 and x cannot be negative 2. So since it can't be those values, I'm going to use my interval notation to write my domain out. And I'm going to say my domain, I'm going to write it above here because I'm running out of room, is going to be from negative infinity to negative 3 to negative 3, and then it's going to be from negative 3 to negative 2, and then it's going to be from negative 2 to infinity. That's my domain. And again, because it can't be negative 3 and it can't be negative 2. So there's my domain. Now, this graph is going to be a little bit harder to, this function is going to be a little bit harder to graph. So what I want to do, and you'll notice it says this on the domain, it says after you do this, factor the numerator denominator and see if I can do any cancellation. Well, I didn't do that on example 1 because there wasn't anything to factor or to cancel. But I'm going to do this on this example. I'm going to say that x squared plus 3x over x squared plus 5x plus 6. I'm going to factor that. And the top is going to be x times, what, x plus 3, right? And on the bottom, I get, well, I already factored that before. That's going to be x plus 2 times x plus 3. And then look what happens here. Because I've got some similar factors, I can cancel out the x plus 3's. And that means my actual final graph or my final function that I'm going to be working with here is x over x plus 2. And this is an equivalent function, and I'm going to go ahead and graph using this function instead. And this makes things a little bit easier to find my asymptotes and to find my zeros and to find my y-intercepts. It's going to be a little bit easier to plug things into. We are going to come back to the original function in just a moment, but let's go ahead and find the other things that we did on the other graph. Let's find my vertical asymptotes, let's find my horizontal asymptotes, my zeros, my y-intercepts, and then we'll talk about graphing it in a second here. So how do I find, again, my vertical asymptotes? My vertical asymptotes is where I set my denominator equal to 0, right? So I'm going to set my denominator equal to 0. So for my vertical asymptote, I'm going to say, x plus 2 is equal to 0. So x equals negative 2. So for my vertical asymptote, I get x equals negative 2. And for my horizontal asymptote, remember what we do for that? My horizontal asymptote, I'm going to determine if it's bottom heavy or if it is powers equal. Well, in this case, it is both of these are x squared. So it's x squared, and there's a 1 in front of that. There's a 1 in front of that. Since it's powers equal, I know my horizontal asymptote is going to be equal to 1 over 1, which is just 1. So my horizontal asymptote is y equals 1. Let's go ahead and graph our asymptotes while we're here. So I've got, again, actually very similar asymptotes to what I had last time, right? So I've got x equals negative 2 for my vertical asymptote. And my horizontal asymptote, I have one here at y equals 1. There's my two asymptotes. Now, what else do we need? Well, we need our zeros and our y-intercepts. Well, remember, the zeros is going to be where we set the numerator equal to 0. So the numerator, x. So for my zeros, I'm going to say, well, x equals 0. Well, that's easy enough. So my 0 is going to be x equals 0. So when x equals 0, I get 0. So 0, 0 is my is my 0 for this, one of my points for this graph. And then what about my y-intercept? My y-intercept, well, remember we set x equal to 0, right? says y-intercept, set x equal to 0. So we're going to set x equal to 0. So I'm going to get 0 over 0 plus 2. Well, that's just going to be 0 over 2, which is just 0. So my y-intercept is also, which we kind of knew, since the x-intercept was 0, 0, the y-intercept was going to have to be 0, 0 as well, right? So let's plot those points. Well, that only point I have here is that 0. So I'll do that in blue. So here's my point at 0, 0. Now I need to do some interval work. So let's do some interval work. So I'm going to go ahead and just give you some points that I went ahead and plugged in. Well, we'll go ahead and plug these in here. So I'm going to use the points. Let's plug in -1. If I plug in -1, I'm going to get -1 also. I'm going to plug in -4. If I plug in -4, I'm going to get 2. And I'm also going to plug in, let's plug in 2. And if I plug in 2, then I'm going to get 1/2. So I plugged in those values for x, and those are the values that I got. You can double check those if you like, if you don't trust me. But I did those ahead of time. So let's plug in those points. I got -1, -1. So that's going to be this point right here. I've got -4, 2. So -4, 2 is going to be right about there. And then I've also got 2 and then 1/2. So that's going to be right about here. So you can kind of see where this is shaping. Now, before I draw these graphs, there's one other thing I want to go back and talk about that we have to put here as well. Do you remember the original graph? The original function was this guy right here. And we found, because the x plus 3 is canceled, we determined that our rational function that we could go ahead and use to solve was this function right here, this x over x plus 2. But the original function had that x plus 3 in the denominator. Because it had an x plus 3 in the denominator, and remember, we figured out with our domain, x cannot be -3. We're not going to have an asymptote at -3, but our graph, even though it's equivalent to x over x plus 2, our graph can't go through the point -3. Because if I plug in -3 into my original function, I'm going to get a divide by 0. I can't do that. So even though I eliminated the x plus 3's, it's still going to be a hole in my graph. So what I'm going to do is, I'm going to plug in -3 into my new function, and I'm going to get -3 over -3 plus 2, which is going to be -3 over -1, which is going to be 3. So that means at the point -3, 3, I'm going to have a hole, and that's what I'm talking about right here. And what do I mean by a hole? That means I'm going to plot that point, -3, 3. It's going to be right, I'll do it in blue. It's going to be right here, but it's not going to be a point that I'm going to color in. It's going to be a single point on my function that's a hole. I can now graph my functions just like I did on the other ones. I've got a curve that's going to hug my asymptotes. Let's do this in red, just to be consistent with my graph. Here's my hole, and notice, or my curve, and it's going to skip through that point -3, 3. That's a hole. And again, why is this a hole? Because x cannot be -3, because in my original function, I had an x plus 3 factor right here, and this says that I can't have -3 as one of my x values because I'm going to get a divide by 0. Even though they canceled, and this x over x plus 2 is an equivalent function. So I'm going to graph this, and it's going to hug that asymptote. And there is my rational function graph. Now, the only thing left to do is calculate my asymptotic behaviors and my end behaviors. Let's do the end behaviors first. So the end behavior, the limit as x approaches -infinity of f of x. Well, what's happening on my graph as x is getting closer and closer to -infinity? What's happening to my y values? My y value is getting closer and closer to 1. And then what's happening? What's the limit as x approaches infinity of f of x? My graph is getting closer and closer to 1 as well. So there are my limits for the end behaviors. Now, what are my limits going to be for my asymptotic behavior? And again, I'm going to put on graph. So I'm going to go ahead and label them up here. So what's happening on this one up here? The limit as x approaches -2. And again, from the left, the limit of that is going to be infinity because I'm going up all the way up to the top, way off the page. And then down here, the limit as x approaches -2 from the right-hand side of f of x, that's going to be infinity because I'm getting, or sorry, negative infinity. What am I talking about? Negative infinity because I'm getting my graph's going down to negative infinity. And that's very similar to what we just saw in the other graph as well too. So there are two of the problems worked out. Notice the only real big difference between number 1 and number 3 is number 3 had some factors that canceled, and that produced a hole in my graph, and that's very important. So make sure if you have any factors that cancel, it's going to produce a hole in the graph. So I've gone ahead and done numbers 1 and number 3 for you. If you can go ahead and complete the others, that'd be fantastic. If you have any questions, please talk to your teachers via email or via the discussion boards. And we might work out some problems for you a little bit later, but give these a shot. Numbers 2 and then 4, 5, 6, and 7, and go ahead and complete the worksheets. So that'll be 5 problems. That's your math assignment for this week. And be sure to make sure that you take a picture or scan it in or do something so that you can upload it to your assignments. If for some reason you can't get that to work, email I'm sure would be fine as well. And that's it for today. I hope this went well for you, and we will talk to you soon.